All right. Hi. Let's keep going. Unit 4, PowerPoint number 3. We're doing great, guys. Today we're going to be talking about the sum and difference identities, as well as finding the exact value using those sum and difference identities. All right, so just to briefly overview what we've gone over so far, PowerPoint number 1, we talked about the 5 types of fundamental trig identities. PowerPoint number 2, we started taking a look at verifying trig identities, right? Okay, so let me share my screen and let's move on to PowerPoint number 3, right? So now we're going to be taking a look at the sum and difference identities and also finding the exact value using these identities, right? So the objective for the day, for this video I should say, is I can identify and utilize the sum and difference trigonometric identities to find the exact value of trigonometric functions. All right, cool. So let's break this down now. We're going to identify and utilize. So not only are we going to be able to learn these identities, take a look at them, be able to recognize what they are, but we're also going to be utilizing them. We're going to actually apply them. We're going to plug in numbers. All right. Now also we're looking at sum and difference identities. So this is different from the other ones that we've learned. This is going to be a new set of identities. And we're also going to do this thing called finding the exact value. So we're not going to find an approximate value. We're going to find an exact value of a trig function. All right. So when we're talking about functions, right, we know there's an input and an output. So what does the exact value mean? Well, we're going to find the exact value of the output. All right. So that's all that's happening here. All right. So let's keep going. All right. Here is an overview of the five fundamental types of trig identities that we've taken a look at so far. So reciprocal, Pythagorean, cofunction, even and odd quotient identities. Hopefully at this point, these feel familiar. They should, right? Okay, let's keep going. So really quickly, before I go into introducing the sum and difference functions, I want to just take a quick look at reviewing the circular functions in general, right? I said that wrong. Before we look at sum and difference identities, let's take a look at circular functions. That's what I meant to say. All right. So if you remember the circular functions, that talks about our 6 different trig functions as we apply them to the unit circle. Hence, circular functions, right? We're talking about the unit circle. We're going to call them circular functions. So let's just quickly remind ourselves of that, right? So remember that on the unit circle, right, the coordinate points x, y represent the respective values for cosine, sine at that given angle, right? So here's some examples, right? If we're looking at cosine of 5 pi over 6 radians, we're going to look at a unit circle. We're going to find 5 pi over 6. Here it is right here. So here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 right here. All right, and this is the exact same thing as 150 degrees. So if we look at this coordinate point that is formed by this 150 degree angle, or this 5 pi over 6 radians angle, right? The coordinate point right here that meets the outside of the circle is negative root 3 over 2, comma 1/2. Well, if we're taking a look at the cosine value, then that's going to be the x value in our coordinate point, or the first number in our coordinate point, right? So the first number in our coordinate point, the x value, that represents our cosine. So if we're talking about cosine of 5 pi over 6 right here, we're just going to be looking at this first number right here, negative root 3 over 2. So that's your answer. And that is the exact answer, right? You could plug that into the calculator, negative root 3 divided by 2, right? You can plug that into the calculator and you're going to get some crazy number that's like 0 point whatever, right? And you can give me the first 10 decimal points of that number, but you are never actually going to give me the exact number, right? That's an irrational number. It's going to go on for infinity. You are never going to be able to tell me in decimal form what that exact number is. So that's why we represent it as negative root 3 over 2, because that is an exact number. That represents the exact value of cosine of 5 pi over 6, right? Let's try a different example. So let's talk sine of 7 pi over 4, right? Well, here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 right over here. So that's the same thing as 315 degrees. All right, and again, so here we're looking at this red dot, right? We've got negative root 2 over 2, or positive root 2 over 2, comma, negative root 2 over 2. So we've got x, comma, y. cosine, comma, sine. So if we're looking at first sine of 7 pi over 4 radians, we're going to take a look at the second number, our y value, right? So that means from y equals 0, right, we're going to go negative root 2 over 2, and that is this coordinate point right here. That is our sine. That is our y value, negative root 2 over 2. So that is the sine of 7 pi over 4. Again, you can plug in negative root 2 over 2 in the calculator and you're going to get some weird, wacky, irrational number that you're never ever going to be able to describe in terms of decimal form. That's why we leave it as a square root and a fraction, because that is in fact the exact value. Notice that word exact value. We talked about that in the objective for the day, right? The exact value. So when we're talking about exact value later today, we're going to be using these numbers, these exact numbers that are given to us on the unit circle, okay? So really quickly, before we move on, we do have to do a little bit of summary just in terms of like remembering how to add fractions, right? Quickly, what was I going to say? Right. The reason that I have to do a summary of this, right, is because we are going to be adding fractions and subtracting fractions for that matter, right? And just like we went over in the last video, finding the common denominator, we are going to have to do that here, right? And the reason that is because the words sum and difference, when we're talking about sum and difference identities, refer to addition and subtraction, right? When you add two numbers together, the result of that is the sum, right? 1 plus 2 equals 3. 3 is the sum of 1 and 2, or the difference, right, when we're talking about subtraction. So 3 minus 1 is 2. 2 is the difference of 3 and 1, right? So sum and difference theories, that should, not theories, identities, sum and difference identities should get you thinking in terms of adding and subtracting, right? So now we have to remind ourselves how to add fractions, because when we're looking at the different radians in the unit circle, right, these radians are written in the form of a fraction, okay? So let's take a look at an example right here. We've got pi over 2 plus pi over 2, all right? So how would we do this? Pretty simply, we have a common denominator, right? So we just add across the top, right? So we do 1 pi over 2 plus 1 pi over 2 is 2 pi over 2. Pretty simple. And then we can also simplify this fraction. So it's no longer 2 pi over 2, right? Because we can simplify the top and the bottom by dividing by 2, right? We can take 2 pi divided by 2, and we can also take 2 in the denominator and divide it by 2, right? And we would just get pi, right? So 2 pi here at the top divided by 2 would just be 1 pi, and then 2 here in the bottom divided by 2 would be 1, and pi over 1 is just pi, right? So think about it this way. You've got half a pi plus half a pi, so that's 1 full pi. Yeah? Let's keep going. Let's try a different example. Here we've got 7 pi over 12 plus pi over 12. 1 pi over 12. Still, again, we have a common denominator, so that's pretty easy. We can just add across the top, add across the numerator. So 7 pi plus 1 pi is 8 pi, and then over 12, right? Because we have that common denominator. Again, we can simplify this fraction. So we can divide both the top and the bottom by 4. In this case, right? 8 and 12, we can divide both of those by 4. So 8 divided by 4 is 2, and then 12 divided by 4 is 3. So we'll get 2 pi over 3. All right, all we're doing is simplifying the fraction, okay? And then just treat pi as if it's a variable. It stays consistent the entire time, right? It's not canceling out, it's not leaving, it's not disappearing. Keep the pi, yeah? Okay. And here's our last example. We're looking at 7 pi over 6 plus pi over 3. Now, we have a little of a problem here, right? We don't have a common denominator. We need to create a common denominator. Well, 6 and 3, right, can actually have a common greatest factor. I don't think that's the right word, right? But we can turn this 3 into a 6, yeah? So hopefully we remember how to do this from Algebra 1, maybe even prior, right? So if we multiply this fraction right here, this 1 pi over 3, right? If we multiply both the top and the bottom by 2, then we'll get 2 pi over 6. And then If 2 pi is over 6, then we have a common denominator of 6, right? So imagine right here, I forgot to put in the little slide right here, so I'm sorry, or the little snippet picture where we see pi over 3 is equal to 2 pi over 6. But just bear with me, right? We'll suddenly be looking at 7 pi over 6 plus 2 pi over 6. And then 7 plus 2 is 9 pi. And again, as 6 as our denominator. So it'll be 9 pi over 6. Again, we created a common denominator by multiplying both the top and the bottom of this fraction right here, pi over 3, by 2. So then we got 2 pi, and then we got 2 times 3, which is 6, and that became 2 pi over 6. And then we added 7 pi to 2 pi over 6. And 7 plus 2 is 9. So we got 9 pi over 6. And then again, just like how we did before, we can simplify this. We can divide the numerator and the denominator by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. So then we'll get 3 pi over 2. Again, the pi stays there. The pi doesn't disappear. Okay? Treat it like it's a variable. It's not going to disappear anywhere. Okay? You keep the pi. All right, so that means that, for example, number 1 here, pi over 2 plus pi over 2 is just pi, 1 pi. 7 pi over 12 plus 1 pi over 12, 2 pi over 3. And then 7 pi over 6 plus pi over 3, that's the same thing as 3 pi over 2. All right, so we just got to get used to creating the common denominator and simplifying our fractions. And then notice this right here, pi, 2 pi over 3, and 3 pi over 2, those are all given to you in the unit circle. You can find those pretty easily in the unit circle. They're written out, okay? And that's what's going to be useful. So let's keep going. These right here are the sum and difference identities, all right? So we've got 1, 2, 3, 4, 5, 6 of them, all right? 2 of them represent sine, 2 of them represent cosine, and then the last 2 represent tangent. So we've got sine right here as this first example, right? Sine of A plus B equals sine of A cosine B plus cosine A sine B. All right, what are these A's and B's, right? We didn't use A and B before. Well, we did an A squared plus B squared equals C squared, but that's not what we're talking about anymore, right? What we're actually doing here, or what our A and our B represent, are just 2 different angles, all right? In terms of radians, right, because we're using radians. So we're not going to be using degrees because I've taught you radians, so we're going to keep using radians, and that's why we've been adding our fractions together, right? So just going to have you write all of these down. You don't necessarily have to know where these derive from. That's okay, but make sure you have these written down because these are a pretty useful set. Now, I will say that the tangent identities, when it comes to sum and difference identities, aren't the most useful. At least we're probably not going to be using them in the scope of our class, but the sine and cosine ones are pretty useful. Now, keep in mind, again, we are using radians, we are using pi, we are using radicals to find the exact answer, to find the exact value. So despite the fact that you might know how to do these identities by plugging them into a calculator, I don't want you to plug them into a calculator. That's not going to be helpful, it's not going to be beneficial, and it's not actually having you apply the unit circle to what's happening here, okay? So let's try some examples together. If you need some more time to write these identities down, go ahead and pause right now, but I'm going to keep going. So here's an example. Here I have all of the identities here. I might have to move my little face out of the way. Okay. So here are the sum and difference identities, and then here's also the unit circle, okay? So just put in the numbers, then use the unit circle, right? So here's the identities, so we can put in the numbers, and then we'll use the unit circle. All right, so we're given the example of sine 3 pi over 4 cosine pi over 2 plus cosine of 3 pi over 4 sine pi over 2. All right, that looks like a monster. That looks really difficult. That looks like we're never ever going to be able to find an answer for that unless we plug it into a calculator. But I promise we can, and we will. All right, so what we're going to ask ourselves is, which identity do we use? Well, we've got sine cosine plus cosine sine. So let's take a look. Which identity is sine cosine plus cosine sine? Well, it's this first one. Sine A cosine B plus cosine A sine B. It's this first one right here. And that is equal to sine of A plus B. Notice, right, we've also got sine of A minus B, and that is, you've got sine cosine minus cosine sine. Then when you look at cosine A plus B, right, you got cosine, cosine minus sine, sine, and cosine A minus B is cosine, cosine plus sine, sine. So take a look and just figure out which one it is. In this case, like I just said, it's gonna be this first one. All right, so we've got sine of an angle times the cosine of the other angle plus cosine of the first angle times the sine of the second angle. And that is all equal to sine of A plus B. All right, so all we have to do is just take the sine of A and B. Well, we have to ask ourselves, what's A and B in this circumstance? Well, these are two different angles that we're looking at, right? So we're looking at this A and this B, right? 3 pi over 4 and pi over 2. And again, that gets repeated, right? 3 pi over 4, pi over 2. That's how we know that those are our A and B values. And you don't have to add all of them together because it's only asking for one A plus one B. So all you have to do is 3 pi over 4 plus pi over 2. That's all. And then you take the sine of that. All right? So sine of 3 pi over 4 plus pi over 2. Notice, we don't have a common denominator, right? We can't just do whatever we want with these fractions. We have to create a common denominator so we can add them together, right? Oh, okay. So the common denominator that we can use is 4, right? So we can take this pi over 2 and we can multiply the numerator and the denominator by 2, and we'll get 2 pi over 4, right? So let's say you have a pizza, right? You cut it into fourths. So you have 4 pieces of this pizza. You've got, and then you decide to take a look at 2 of them. 2 out of 4, right? Well, that's half the pizza. And that is how you know, right, that pi over 2 is the same thing as 2 pi over 4, right? So if we've got 2 pi over 4 plus 3 pi over 4, which is our angle A, then that's 5 pi over 4, right? So 3 pi over 4 plus pi over 2 is equal to 5 pi over 4, all right? And all we have to do now to get this answer right here is just take a look at our unit circle and find 5 pi over 4. So we got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. It's right here. It's the same thing as 225 degrees. All right, so we're taking a look at this red dot here in the third quadrant, right? And if we want to find sine, sine is the y value. So here's x comma y, cosine comma sine. So sine is the second number right here, negative root 2 over 2. So then this big monster of an equation right here, sine of 3 pi over 4 cosine pi over 2 plus cosine 3 pi over 4 sine pi over 2, all that is just equal to negative root 2 over 2. That's all. And that is how you find the exact value. All right, so here's another example. We're going to do this one together. All right. Well, can't really do it together. I'm just going to do it, right? Because this is just me and this is a video. Right. Okay, we've got cosine 3 pi over 2 cosine pi over 2 plus sine 3 pi over 2 sine. Yeah, I'm not crazy. Sine pi over 2. So we've got cosine, cosine plus sine, sine. All right, let's take a look. Which one's cosine, cosine plus sine, sine? This one right here. Cosine A, cosine B plus sine A, sine B, and that is all equal to cosine of A minus B. All right, so now we're just going to take a look at this easier side, right? So just like how we did with our verifications and stuff, we started off with the harder side and we tried to prove the easier side. Here, again, we're given the harder side, and we're just going to take a look at the easier side to help us out. All right, so we're going to plug in our A and our B values. In this case, A is equal to 3 pi over 2, B is equal to pi over 2. And again, A, B, right? Cosine A, cosine B, sine A, sine B. So now we know that it's supposed to be cosine A minus B. So we've got cosine of 3 pi over 2 minus pi over 2. We have a common denominator. Perfect. This one's super simple. So we've got 3 pi minus 1 pi, which is 2 pi, right? This should not be sine. This should say cosine. My bad. It's okay. I'll fix it in a second. That's all right. We've still got 2 pi over 2, right? And 2 pi over 2 is the same thing as pi, right? We can simplify that. You've got 2 halves is just 1 whole. So we're going to take a look at cosine of pi, which in this case, I, for some reason, did this PowerPoint incorrectly. But if you look at the cosine of pi, right, I'll give you the correct answer right now. We'll take a look right here. We've got cosine of pi right here. Pi radians is the same thing as 180 degrees. And cosine, right, is our x value. Cosine comma sine, x comma y, cosine comma sine. So our x value, -1, is our cosine. And -1 would actually be the correct answer for this problem. I'm not sure why the slide is like that. I'll fix it eventually. All right, and we can't really do the you do, but here's another example where I actually do the numbers correctly, all right? So if you wanna try that one out on your own, you should. So here, let me go back, pause, and you can pause the video. You can try this out on your own if you really want. Okay, and all right, one final thing that I want you guys to keep in mind. Let's take this back to unit number 1 when we talked about coterminal angles, right? Well, coterminal angles, when we first learned them, we talked about degrees, but we can also use them in terms of radians, right? So if you just remember that 360 degrees is the same thing as 2 pi radians, then you can also do coterminal angles in terms of radians, right? So here's some examples, right? We've got 9 pi over 4 radians. Well, here, I have them actually in these like neon green are the numbers that we'll be taking a look at. So this is what we're going to do. We're just going to count out 9 pi over 4 radians to find the coterminal angle, all right? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and wrap one more time around 9 pi over 4. And notice that we landed right here on the same terminal angle as just 1 pi over 4 radians, or 45 degrees. All right? So that's how you would do the coterminals when it comes to radians. All right? And let's try here. We've got another example. Why not? 16 pi over 6, right? So here's 1 over 6. So we'll be taking a look at all of the blue numbers right now. So here's 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6, 11 over 6, 12 over 6, 13, 14, 15, 16 pi over 6, right here. And that is coterminal to 2 pi over 3, which is the exact same thing as 120 degrees. So then you can use these coordinate points, the same coordinate points for 2 pi over 3, you can also use that to answer 16 pi over 6. So that means the cosine of 16 pi over 6 is equal to the cosine of 2 pi over 3. So if I ask you, hey, what's the cosine of 16 pi over 6? You'll look at this x value and you'll tell me -1/2, right? If I ask you for the sine of 16 pi over 6, you'll tell me √3 over 2. And it's the exact same answers as 2 pi over 3, right? This is the cosine, this is the sine. Right, so that's the last thing you guys had to keep in mind. So let's just do a quick summary, right? Again, you can use the tangent identities as well, but like I said, they're not as common. The sine and cosine ones are going to be used a lot more. So the point in the PowerPoint right now was to make sure that we're finding the exact value of the trig function and not just using the calculator, all right? Just be careful with like making sure you're using the right identity, right? Just be careful of how you're doing your addition and subtraction, and the order of the functions, right? Like don't mix up cosine, sine, cosine with cosine, cosine, right? Just find the correct identity. Be careful of using the correct identity, and then just also be careful of how you're adding your fractions, finding the common denominator, and also be careful of how you're finding the circular functions. Don't do the mistake that I made here when you're looking for cosine and then you accidentally find sine. Don't do that. Learn from my mistakes, all right? And then again, there's that worksheet that you guys can finish. That is 1113, okay? We got one more PowerPoint to go. I hope these videos are helping you guys.